No chain without a chain wheel. The self-adjusting chain wheel. The enormous conflicts of interest between the chain manufacturers, such as the companies Ketten Wulf, Ketten RUD, etc., on the one hand, have a small inventor as well as many operators of plants, operated with chains on the other hand. Two of these self-adjusting chain wheels have their birthday this month of April 2021. They'll be 20 years old, and they are still working in a portal scraper reclaimer of the otherwise shut down power plant in Ensdorf in Saarland, Germany. You can see in this picture a self-adjusting chain wheel invented by Karl Herkenrath. Anyone who uses chains knows that with every conventional chain wheel, after a certain running-in period, the constant load from the chain is only ever applied to the first tooth in the mesh, and this one tooth is naturally subjected to enormous stress over time. This inevitably causes that a chain must be replaced after some time, already for safety reasons. In such cases, the two chain wheels are usually replaced as well. A conventional chain wheel has fixed teeth, and only ever the first tooth does all the work. Wear reduction. Low load on pins, chains, and chain links. Low noise due to spring compensation. Low entry shock. Maintenance-free due to self-adjusting chain wheel. With the self-adjusting chain wheel, however, the forces are absorbed evenly by all the meshing teeth. This significantly reduces the stress on the individual tooth and thus protects the chain. All teeth are arranged to be movable via pins. There are recesses on both sides of a tooth element, each of which, in conjunction with the adjacent elements, accommodates an elastic round spring. For example, those made by Connex AG, Switzerland. The tooth elements arranged in this way form a radially stable sprocket with inherently flexible tooth elements that are able to perform small titling movements and then transmit these to the neighboring teeth. If a force acts on any tooth, the flexible arrangement generates a torque which is transmitted via the round springs to all subsequent teeth, i.e., also back to the first loaded tooth element. In this way, all teeth are involved in the force distribution, and not only the first tooth bears the load, as in the case with conventional chain wheels. The idea of moving tooth elements also has other positive aspects. The self-adjusting chain wheel can compensate for inaccuracies in the pitch of the chain and chain wheel, which can never be completely avoided, and which are caused by wear, stretching of the chain, and/or manufacturing tolerances. Entry shocks are also cushioned by the round springs. How to replace individual teeth of the chain wheel. If individual teeth of the new chain wheel ever need to be replaced, the wheel does not need to be dismantled and the chain does not need to be dismounted either. This saves a lot of time and money. By using the self-adjusting chain wheel, the unbeatable advantage is that you can assume a significantly longer service life for the chain due to less wear, which is associated with enormous savings. The teeth can also be turned around if necessary. Further savings result from the fact that the teeth can simply be turned around should they show signs of wear after years. Previously, you had to replace the entire chain wheel. A living example, so to speak, of this incredibly long service life can be seen in a portal reclaimer located in the now decommissioned power plant in Ensdorf, Saarland, Germany, which has now been in operation for more than 20 years. This power plant has been shut down several years ago, but the portal reclaimer is obviously still in use. It is now in April 2021. That's over 7,300 days ago, two self-adjusting chain wheels were installed in this portal reclaimer, together with a chain from Ketten Wulf. According to my husband's old patent, neither the chain nor the two chain wheels have ever been replaced in those 7,300 plus days. This picture was taken 20 years ago in front of the portal reclaimer during a startup and shows on the left Mr. Bertel from the Coke Company, who at the time showed the courage to successfully enter new territory in the field of chain wheels. And on the right, the inventor, Karl Herkenrath. Here you can see the chain wheel in the test field. The individual two segments of the chain wheel can be seen well. The predecessor patent of today's improved patent was previously tested on a chain simulator over a longer period at Ketten Wulf in Saarland. After it was found that the reduction in wear was already 30%, the test was discontinued. There is also a test report dated 23/2003, but the Ketten Wulf Company does not want this to be published. More information can be found on the homepage, www.Selbsteinstellendes-Kettenrad.com. The test on the chain simulator involved testing the wear behavior of two identical strands on two different chain wheels, namely a chain wheel from Ketten Wulf and the self-adjusting chain wheel. The test report ends with these words, I quote, "Result: I can be concluded from the evaluations and the diagram of all test specimens on the chain wheel. Herkenrath show lower wear compared to the Ketten Wulf wheel. Furthermore, the tests show that the Herkenrath chain wheel has a particularly positive effect in the case of increased wear." This picture shows the inspection and approval of the production at the Saarland mines plant from 1402 to 1602-2001. At that time, nobody would have believed that these two self-adjusting chain wheels have now been in use for more than 20 years. Here you can see the test run of the reclaimer on 19/4/2001. The inventor, Karl Herkenrath, had invited the Saarbrücker Press, which was at the Ensdorf power plant, for a photo session in May 2001. On these pictures here, you can see a schematic representation of how it works. Each tooth segment of the chain wheel is rotably mounted under the tooth center and is provided with recesses on both sides to accommodate the transmission springs. Springs are located between the individual teeth. When a force is applied to any tooth, a torque is generated on that tooth. This torque is transmitted evenly via the springs to all subsequent teeth. Frictional losses are reduced in the process. The chain force F on tooth 1 generates a clockwise movement, and thus a counterclockwise moment acts on tooth 2, acting in the opposite direction to the direction of force. The chain and the tooth pitch prevent tooth 2 from titling further, and a balance of the forces on teeth 1 and 2 is achieved via spring 1. With the adjustment of teeth 1 and 2, tooth 3 moves out of the direction of force, and thus the pitch distance changes. As a result, tooth 3 is not involved in the transmission of force to the chain. Nevertheless, tooth 3 is involved in torque transmission via spring 2. This compensates for the change in pitch due to wear with tooth 3. After an equilibrium of forces has been established on teeth 1 to 3, tooth 4 rotates against the direction of force, and thus tooth 4 is involved in the transmission of force to the chain via spring 3. Since the same torques act on each tooth, the load on chain and tooth are also the same. Thus, 4 teeth are engaged, of which 3 teeth bear almost 1/3 of the force. For all subsequent teeth, systems 1 to 3 and then systems 4 are repeated until the first tooth is reached again, and the moment chain is thus closed on the teeth. This process from system 1 to system 4 constantly changes, from the first tooth to the second tooth, and so on. In this photo, you can see the stress from the point of contact at a tensile force of 120 kilonewtons on the first engaged tooth. Above, you can see a normal rigid chain wheel, and below, the self-adjusting chain wheel, where you can observe a significant difference. Anywhere in the world, this self-adjusting chain wheel can be built and used. This self-adjusting chain wheel, which could save considerable costs and massively protect the environment, could also be used in Germany. In Germany, however, it is a patent protected until a manufacturer acquires the patent right, builds the self-adjusting chain wheel, and it can then also be used in Germany. The self-adjusting chain wheel can of course not only be used in such a large device as the portal reclaimer, but all chain-driven equipment can be equipped with the self-adjusting chain wheel, and of course also retrofitted. In 2011, this chain pin was dismantled for the inventor Karl Herkenrath at his request from the Ensdorf power plant, which was still in operation at the time, and as you can clearly see, it shows no signs of wear. And even today, after another 10 years, the portal reclaimer with 2 self-adjusting chain wheels is still in operation. Here you can see some examples of the possible applications for the self-adjusting chain wheel. All about this self-adjusting chain wheel and also some more interesting photos and unbelievable experiences with the German chain industry can be found on the homepage of Karl Herkenroth, www.Selbsteinstellendes-Kettenrad.com. On the homepage, you can also download the book. Download for free as a PDF file. This book is available in German and in English, and was downloaded over 5,000 times in the month of February 2021, mainly from abroad.